Now, we've booted into Clio, we've got Clio running, we've got the drives inserted, and we've logged in. So I'm currently logged in as root. So what we're going to do is we're going to have a look and see if the drives have been detected. And we can do that by going dmessage. Now that lists all your boot messages. And you can see right at the top there we've got DA5. Okay. Now because that drive's obviously on a SCSI bus or a SAS card, they get the prefix of DA. So we can actually use a pipe these messages into another tool called grep. And we're going to look for anything which has DA in it. And there we have it. And we've got DA1, obviously we can do that again for DA0, and there it is. So we have 6 new drives on top of ending our 2 boot drives. Excellent. So let's have a look at what partitions we have. So we'll go G part and we'll go show. Okay, so it's only showing the 2 drives. That's fine because the other 6 haven't been set up yet. And we're going to get onto that. At the moment we're looking at the 2 drives. And this is what BSD's been installed. And you can see there a mirror copy. And we can go have a look at our ZFS. And there they are. You can see the Z root pool. Now, ZFS is a file system, but it's also a volume manager as well, all rolled into one. And everything is organized into pools. So in this here, we've got the Z root pool that was created when we installed BSD. And we can actually have a look at that. We can look at Z pool. Oops. History, Z root. And these are all the commands that are run when that pool was created when we installed BSD. And you can see there's all these little mount points and all that. So we won't go in that too deep. But let's go back and so you got your pool. And you can see under that pool you have what's called mirror-0. Now that's a VDEV, or virtual device, if you like to think it that way. That has the 2 partitions on the 2 drives underneath that. So any drive, and when you set up, go into a VDEV. In this setup we have a mirror. So those 2 drives, we can even add another drive to it, and they all become mirrors of each other. So if we add drives to the mirror VDEV under the pool Z root, it's not going to grow in size because that's not how mirrors work. Now what we're going to do is we're going to install OpenZFS. Now to do that, we're going to need PKG. Now we already have done that, but what we haven't done yet is we're going to change the configuration from using the quarterly tree to the latest. Now this is easily done in the FreeBSD handbook on the FreeBSD website. It actually explains how this is done. But we're actually going to go through it here, changing our setup. So first of all, we're going to need, it's always good practice, anything that is basically customized to your machine should end up in your user local directory structure. Because if we go into etc directory, change directory, of course, a list, you'll see there's a folder called PKG, and when we look in that folder, there's a FreeBSD conf. Now we can have a look at that file, and you see there's a URL And on the end of that line, you see it's quarterly. Now we can just change that to latest, but that's actually not good practice. In FreeBSD, we should actually put any changes we want in the user local. Now this is how we're going to do it. So first of all, we're going to need to create the directory to put this file into. So make dirt, or make directory, dash P is the switch we want, slash user local. Now you see this is etc under user local, package, and we're going to create a folder called repos, as per the handbook. Now we're going to copy that file we just looked at. Now I don't need to do the full path because it's already in that folder, but I'm going to do it for argument's sake, because if you're not in that folder, it won't work. But if you specify the path, you know you should be right. bsd.conf, and we're going to copy that and we're going to plonk that into user local etc pkg repos. Now, and we'll specify the file name that we're copying to. Done. And I'm going to cheat. Now we're going to switch into that directory. Oops. Should have taken that off the end first. And there's our file. I'm going to use the base file editor, bsd.conf, and we're going to change, we're going to go to URL, and we're going to change that to latest. Now, by default, the pkg.freebsd.org is the default location where it'll look to. But what it will do is it will look for a local mirror. Now, if you can actually change this line to actually, if you want to go to a very specific package server, whether or not you created your own, or you have a local one that you would prefer, another one that you prefer over your local one for various reasons, this is where you would change it. But at the moment, we're not going to bother. I'm quite happy to leave it as it will go and find it for you. So we've done that. To save, it's very easy. We'll just do the easy way. Escape, leave it in a, and it says, oh, you got changes. Yes, we'll save them. So if we cat that file, concat that, oops, and there it is. So I've already installed pkg, but I need to update the database with the package. Ooh. I must. Typo. That will happen if you don't have it typed. It's latest, not lastest. Silly me. Now that'll work. So here we go, it's just pulling the package. So we do package, and we can do this thing called the search. So we'll look for the packages that we want. And there they are. To install, it says pkg install, and we want the OpenZFS-kmod, and we want OpenZFS package, which is the userland tools. Like one we just shown you, like zpool, z. So we need to update the pkg itself. We go yes, and download it. Depending on the speed of the interconnection. Now these are the packages we install. So we asked for OpenZFS and there's OpenZFS kmod, but it turns out we need the other two, so that's fine. Let's pull down all the dependencies for you. And now this can take some time, depending on your internet connection. and didn't take that much longer. So you see there, we need to edit the bootloader. So what we can do is we'll change into cd boot. Let's have a look. There's our loader.conf, so we'll edit loader.conf. Now we'll need to change that to no. Now we do need to change that, so I'll just double check what we need to change it to. If you are not confident in changing your boot settings without, you don't have to do this, you can skip this part altogether. I'm just doing it because I can. I'm just hopping onto the fresh ports page, because that message that you see is also on the actual ports package site on. So I just want to verify that what I'm changing it to is what I want it. So we need to add open ZFS underscore load. Yes. I actually had that on my VM here. Open ZFS. So we need to make sure there's no typos. So open ZFS underscore load equals yes, and we got ZFS load equals no. You can see these top 3 lines are actually from when we install BSD. These are the security things you can turn on and off. But we're not going to talk about that to now, so we just save our changes. Now to apply those changes, we need to reboot. So shut down -R for reboot, and we want to do that now. But before we do, I'm a bit paranoid here. Okay, loader.conf, open ZFS, make sure there's no typo, because this will, if we get this wrong, it will render the machine unbootable. And good fun fixing that. So shut down now. Okay, we're back at the login screen. We have now successfully installed OpenZFS, or the updated OpenZFS, because as of FreeBSD 13, it came out with OpenZFS 2. But there's been an update, and it's been made available as a separate package, and that's what we've done. So let's log in. As soon as the weirdness of using the IPMI remote, it's always funny, it's after your first reboot, initially it's a bit wonky. Okay, looks like it's coming good. So we'll switch into the root user again. Now let's have a look at our boot pull. So we go Z pull status. And it's all good. This is interesting. I was actually half expecting a message saying that there's because usually when you update ZFS, they use version flags, and if you're using if you've got modules installed which just has a higher version than what's on your drives, it'll come up with a message saying that, hello, I'm working, which is because ZFS will work backwards compatible with older ZFS versions on the drives. But that's fine. Okay. We now need to set up our 6 drives. And how we're going to do that is through GPart. So we're going to set up. Now what we're going to also do is we're going to take the serial numbers of the drives and use part of or all of the serial number as the drive. And now the main reason is that is if anything goes wrong, you've got a drive that's gone flaky and is producing errors, then you can look at the name and go, that's the drive with that serial number. Now, if you were watching the video up so far, you notice that I put labels. I've actually put the serial number of the drive on the caddy, so I can match. If I've got a drive that's failing, I can just look at it, I can pull that drive, drop in a new drive, and then we'll rebuild the pool. So first things first, we need to set up the drives themselves. So first thing we need to do is we'll get a bit of an idea. So we'll have a look at the message. I'm going to pipe that into grep, and we're going to show our drives. So there they are. We can go to GPart, show, that's our drives. And there is another command we can do. There's a command we can do. And I forgot about it. I was playing with it earlier. Let's have a little GPart. Let's have a look. So what we'll do is we'll GPart list. And there's all that. Okay. Cool. Cool. So what we'll do is we'll do DA01. So I want the serial number of that drive. So let's do DA10. There's a 0. So this is when we create these drives, we've got to decide how we're going to name these drives. You can just do ZFS0, ZFS1, ZFS2, but that doesn't, like I said, we don't have an actual meaning to the drive. Good practice is to use the part of, or if not all, if you're going to go that far, the serial number of that drive as on the label, on the drive disk. And as you see, we have already physically labelled this, written that have the serial number on the label on the caddy itself. So it makes sense to use the serial number in the label on when we create the partitions. So to create the partition, we do GPart create, and we're going to create. Now before we start, we're going to actually. Now we can do this first. So we'll do GPart create. So first thing we're going to do is check a syscontrol. So virtual file system .zfs .minimum auto A shift. Helps if I spelt that right. Now you see that is A shift of 12. What's 12? When you create a use ZFS as file systems create, like, the hard drives are broken up into blocks, and usually the hard drives will advertise what their block size. SSDs have typically, old hard drives use block size of typically about 512K, or no, 512 bytes. Whereas SSDs tend to do 4K or 4 kilobyte blocks, but they'll advertise themselves as 512K for compatibility reasons. And ZFS will try and use the set. But in reality, we want to use the block size better matching with the drive. Now the downside is we do lose a bit of space, so if a file is smaller than that block, well, the rest of that block's not lost, basically, but I digress. So, we want to tell the system that we want to use 4K block sizes. And to do that, FreeBSD from version 10 onwards, 10.18, has this ZFS min auto shift. But what's the 12? Well, that's powers of 2. Yes. Someone looks and sees 12 or 9 and says, oh yes, that's powers of 2. So it's 12, it's 2 to the power of 12, which is actually 4096. If you wanted to set that to 512K, you would change that value to 9, which is 2 to the power 9, which is 512. If you wanted to change the value, you would do the same thing, syscontrol of it, and just go equals 12. But we're already set to 12, so we're going to leave it at that. It hasn't changed anything, it just tells you that, oh yeah, we've done it. That's the same. Now, we do G create, and we want, now, switch S or dash S is the scheme. Now we're going to use GPT, which is the modern partitioning method. The older one used on PCs is MBR or master bit record, but that's the thing of the past. We're using GPT now. And then the drives are named. So this is now we've got the main. So that's the driver. So we have now created the partition table. But we still can't use that drive yet, because we need to add an actual partition to it. So we need to do gpart add. We're going to tell it to align to 1 megabyte boundaries. Now this is where we're going to decide how we're going to label these disks. So, as I said, we want to use the serial number. Now, you can either use the whole serial number, which would be a long label, or you can use the last 4 or the last 8 digits. It's really up to you. There is no hard and fast rules. Just in this case, I can probably get away with just the last 4 digits, because I know all 6 drives have, or even 8 drives on the machine, all have different values. The last 4 digits are all different. So I can go, rightio, I know it's a disk, so why should I use disk? This is where you make the decisions. And I didn't really think about this. So what I could do is we can do, what should we do? What should we do? Well, how about we go ZFS, which is a file system, underscore, and we'll use the last, we can just use a 29, 39, E5, D6, EC97. Pain in the ass. It's probably going to bite me in the ass later. So that's the label. And we're going to specify the partition type to be FreeBSD underscore dash ZFS. Now we're basically saying this partition is a ZFS partition. And then we're going to tell it to put it on, we're going to add it to the drive DA0. And we're done. Now we just need to do all the remaining 5. I might end up speeding this part up. And there we have it. We now have 6 drives, but we can't use them yet. Well, I partitioned them, but we have not actually added them to create a pool or add them to a pool. So the first thing we're going to do is we're going to create a new pool. I think this is going to be painful. Now this is the downside of using long serial numbers, as you're going to see. Now hopefully I can just use zpool, take that, zpool, and we're going to create a pool, and we're going to call zdata. So zpool, create zdata, so it's the name of the pool. And we're going to have, now we're going to tell it what type of VDEV we're using. Now if you don't put something in, it's going to come a stripe. Good for space, good for performance, absolutely no good for redundancy. You lose one drive, our pool's gone. So what we're going to do is we're going to create. So we're going to go zpool, create, and we're going to call zdata, we call it RAIDZ, and we're going to use the partition names. Now what I mean by that, so we'll hop into dev, and you can see that you've got DA3 and then DA3P1. So I'm going to use the actual partition names. So what we're going to do is what I do is I'll list it into grep, so we can just cut out all the others. So we've got P101. So what we do is we go zpool, create, so we create a new pool. We're going to give it a name of zdata, if I can type, and it's going to be RAIDZ Z2, so we're going to use basically the capacity of 2 drives worth for parity. Well, basically it's RAIDZ Z level 2, so we can lose 2 drives before the VDEV is compromised. And then what we're going to do is we're going to do DA0, first drive, partition 1. And we're going to do the same thing, DA1, P1, DA2, P1. So we're just telling the pull command which partitions we're going to use. So DA3, P1, DA4, P1, and DA5, P1. So this is all the drives we're going to use in this array. Now this will put all these drives into one VDEV. The other way I could have done this is have two VDEVs. And that would two VDEVs using Z1. So I still have 2 drives worth for redundancy, but they're split off into VDEVs. So I can only lose 1 drive in each VDEV. So let's create. Now this is, and then we're done. Let's go back to the root directory and we'll do zpull status. Now this is going to show us what we have. Now we've got two pulls. Now you see in ZData we've got a VDEV of RAIDZ 2-0. And they're all the drives we put into it. Now we can do, what we're going to do next is we're going to start creating data sets. Now data sets are groupings, not probably the right word. The data set we're going to create is basically next thing we're going to do is create data sets. Now there's different types. The main one we're going to use is create initially is for files and folders. And it is simple as ZFS. So we're using the ZFS command now. We're not using the pool, so we're not working with the pool, we're working with data sets now. And we're going to create a data set. And we're going to use, it's going to be created in the zip data pool. So we're telling which pool we're using. And then we're going to give the data set name. So this example, I'm just going to use documents. Highly original, I know. And boom. So I can go ZFS list. Now this is all the data sets on this system. So you see at the top we've got ZData, which is the main data set. Then we've got ZData documents. Now you might be asking, so as you notice in ZRoot there's multiple data sets. Now you think, why would you have more than one? Simple reason. If you want, for instance, logging is a good example. If you create a data set for your logs, you can set a variable on those data sets to prevent execution. Well, they're logs, they should be only text files, they should not be executables in there. Your temp, you may set that as a data set. So there's a lot of different reasons why you would create multiple data sets. And so you can apply different policies to them. So I might want a data set for my movies or videos, so I'll create another one. Videos or video. It's up to you. The name of the data set is entirely up to you. And a list. And there we have it. We can actually, if we do a list of our directories, there's ZData, so we're going to, so it's mounted. We're going to ZData, and there they are. I'm going to documents. Let's create a text file. And voila, we're now using that. We actually now have a file on our drives. So, we have zpool status. We now got 2 pools on our system. We have the initial pool that was created when the system was installed is zroot, and it's a mirror, and it's got the drives 80A0 partition 4 and 80A1 partition 4 in that pool, in the VDEVs. And then we got the Z data, and that's RAIDZ2, and we've got the 6 drives that we just installed. Now we can actually increase the size of our pools by adding more VDEVs. As of the new ZFS version, one that we just installed on this machine, you can now add, whereas previous ZFS versions you couldn't, more drives to your VDEV, RAIDZ VDEVs. But we can also now add them, but the other thing with pools, you can add more VDEVs underneath them. Now when you do that, the data gets striped across the VDEVs. So all your redundancy in ZFS is at the VDEV level. So if I was wanting to increase the size of zroot, I would add 2 more drives to the system, create a new mirror under the pool zroot with those 2 drives, and then those 2 VDEVs become part of the pool. So the pool size of the pool would increase. Now when you create pools and add VDEVs to them, it is highly recommended that you stick to the same type. So as the zroot is using mirrors, so if I wanted to extend this, add to the zroot pool, it's highly recommended that I add mirrors, VDEVs that are mirrors. My Z data, if I was going to add to that, I should only be adding more VDEVs that are RAIDZ2s. And the main reason for that is because the redundancy is at the VDEV level, not the pool level. Pools with multiple VDEVs will stripe data across the VDEVs. So if I was to add another VDEV to zroot that is a stripe, or just a single disk mirror, and that disk dies, I have lost that pool. Same thing with my Z data. If I added a stripe to that, a VDEV that's a stripe, and I lose that VDEV, then the pool's dead. So that's when you're creating these ZFS pools and VDEVs, that's something you do have to keep in mind. It's highly recommended that when you decide which VDEVs and how you're going to use them, you should keep your VDEVs the same. It's not to say you can't do it, and zpool will complain, or ZFS would complain that you're trying to add a VDEV to your pool that is different from the already existing ZFS, but you can actually force it. But one of my favourite quotes in the book that I referenced in the making this video: FreeBSD's flexible storage system gives you the power to do stupid things. Don't. With that, goodbye.